together. There's not a lot out of each one that we have to know. So we're just going to touch on the things we do have to know. Deductive reasoning. All deductive reasoning is you're just using logic to figure something out, something that's logical. Like if that segment addition postulate. If you take AB and add BC to it, you have the whole thing AC. Okay, that's logical. So, these statements that we're doing, again, it's going to come up later when we do proofs. This is the easy way to do it. There used to be a whole class. They don't teach it anymore in college. You do these. They're called truth tables or logic tables, where they use P and Q. Now all that is it represents, instead of like when we were doing the if-then statements, here's the hypothesis and here's the conclusion. So if we wrote the if-then, we'd say if the value of x is 7, then x is less than 10. So these are a lot easier because what they do is they just say P is the first thing and Q is the second thing. So you could just write this like this instead of writing out all the words. This symbol right here means it's an if-then. So you put the if in front of the P and then the then in front of the Q. So it's really the same thing we've done, it's just you don't have to write long sentences now, you just gotta go like that. The converse then is just if Q, then P. Okay? So instead of putting the words in there, you just use P and Q to represent those words. You could use any letters, but for some reason they use P and Q when they do these. So if we reverse this, if x is less than 10, then is the value of x 7? True, false? If x is less than 10, is x 7? No, it could be, but not always. So this way is true, this way is false. So, like this last assignment, since this was false, you couldn't write the biconditional. Okay? Inverse and contrapositive. Inverse is the opposite. So the way they show opposite is this little squiggly line right there. So if you see something like this, that means, it's called a negation actually. It means not P. So if you say, if my favorite TV show isn't on, since you put that, then it's not 8 o'clock. So whenever you see these, that just means the opposite of what they're saying. Okay, we don't need that. I'll find the biconditional. Okay, so here we've got some statements, if then. So this is P and this is Q. So it would be written like that. If P, then Q. If a cat's the largest of all cats, then it can weigh 650 pounds. I guess I don't know if that's true. Does anyone know if that's true?
I think it'd be way too big for a cat.
Yeah. I suppose if it's a lion, lions can weigh that much probably. Okay, so well, let's just say that lions can weigh that much. That's true. So if you do the converse, if a cat weighs 650 pounds, then it's the largest of all cats. That's probably true too, I'm guessing, since they put it in there. We'll just say it's true. So if they're both true, then you can do the biconditional. A cat is the largest of all cats if and only if it weighs 650 pounds. Well, no, I'm just saying that, we're just saying these, both of these are true. So if they're both true, then you can write the biconditional. A cat is the largest of all cats. Remember, you don't put the if there, you don't have the then, you put if and only if. Okay? So the easy way to write that with these is you put a double-sided arrow on it. So this is the if and only if. These are if then, and this is if and only if. Okay? Everyone got that? That's really all we need to know is what these symbols mean. If and only if, and these are if then. The other one is the negation. This means if we do this one, a cat isn't the largest of all cats, then the negation means it can't weigh 650 pounds. All right? So that's all we need out of section 2.3 is those symbols. So 2.4 again is kind of for, yeah?
A Siberian tiger can weigh up to 800 pounds.
Oh, wow. Never guessed it'd be that big. Okay, algebraic properties. These are used again when we do proofs. So today it's going to be kind of like a practice. You kind of did this back in 7th grade, solving equations. And this is going to be like an intro to doing proofs. So this is all review for you. The addition property is just this. If you got an equation, what do you do to solve this equation? Add 2 to each side, right? That's the addition property. Whatever you add to one side, you got to add to the other. So the subtraction property is this. In order to solve this, you have to subtract. Whatever you subtract from one side, you do to the other. Multiplication and the division property is the same thing. If you got x divided by 3 equals 7, in order to solve it, you multiply by 3. So that's the multiplication property. If you've got 2x equals 20, to solve it, you divide by 2. Whatever you divide by one side, you divide by the other. Reflexive really isn't used much. What do you see when you look in the mirror? Yourself, right? So, for any real number, A equals A. Something equals itself. 5 equals 5, 10 equals 10. That's all reflexive is. Symmetric, remember what it means to have symmetry? Symmetric? Same on each side. So if A is B, then B is A. These two are basically the same, and when we get to the proofs, you'll see you could use either one. The transitive property says if A equals B and B equals C, what do you know about A and C? They're equal. Substitution is when you put something in place of something else, which is why transitive is kind of the same thing. Since A equals B, I could just put A in place of B because they're equal to each other, and then you'd end up with this. So that's the substitution way, you're just putting it in place of it. So here is what we are doing on your assignment. It's only like 4 problems. It's going to be like an intro to doing proofs. You're going to be given an equation, so you got to write the equation down, and then you're always given something to start with. So the way this goes is the types of proofs we're going to do like that. I'll just do it on the, I better do it here. You have your statement and your reason. This is our statement, and the reason we put it there is because it was given to us. All proofs pretty much start that way. So in this equation now, what's the first thing that you do to solve it? Someone say it.
Distributed.
Distribute. So you would have 12x minus 3x minus 21 equals 8x. You took the negative 3 times there and times there. So the reason I did that is the distributive property. So you put down what you did. Now what's the next step you do? Combine like terms. So that makes 9x. So all I did is combine like terms. Then you have to do what?
Subtract 8 from that, or 8x, that's fine.
Yeah, you gotta get the x's together, right? So since this is the non-x here, it'd be quicker to move this one over. So what do you gotta do to get it over there? Subtract it. Since it's a plus, you minus it. So you're left with negative 21 equals negative 1x, and you just write down what you did. That's the subtraction property. So then, what do you do to get the x by itself? Divide by negative 1. 20 equals x, and what I did was the division property. Okay? Now this is the longest one that you would have to do. Some of them are this easy.
We get to see this, or when you subtracted 8x to 9x.
You would, if you subtracted 8x, brought it over here, you'd get 1x minus 21 equals 0, but then you'd have to move the 21 over, and there you'd have your answer, x equals 21. So here's a simple one. Okay, if we're doing this as a proof, again, that's given to us. What's the first thing you do? Subtract 1. So all I did was subtraction. Then divide by 2. I did division. Okay? So that's a real easy one there. All you're doing is writing down on the side what you're doing on each individual step.
So that's what we're doing on our second.
Yep. So now this one, I'm just going to show you. This is a kind of an intro. We're not going to do any proofs like this, but this is similar to the things that you're going to be doing later. Here they tell us a few things. They tell us that if you add the measure of 1, measure of 2, measure of 3, and measure of angle of 4, it equals 360. Then they say if you add up the measure of 2 and 3, it equals the measure of angle 4. And then they say the measure of angle 4 equals the measure of angle 4. So, again, don't get real worried if you don't get this right away, but this is an actual proof. Eventually you'll have to do one like this. So we've got 3 things given. You always start off with, well, you don't have to, but it's usually the easiest. So that's given. That's given. That's given. So, whenever they have things equal to each other, substitution is usually the thing to do. Since 2 plus 3 equals 4, could I replace this with 4?
Yeah.
Yep, because right here it says 2 plus 3 is the same as 4. So if you rewrite it, I would just rewrite this with the measure of angle 1 plus, instead of this, I'd put the measure of angle 4 plus the measure of angle 4 equals 360. And remember what that's called when you put it in for something? Substitution. Then,
Can't you put 4 in for 1?
yes, so right here, since 1 equals 4, I could put the 4 in for that one. And then I'd have measure of angle 4 plus measure of angle 4 plus the measure of angle 4 equals 360. Again, that's another substitution. You can combine like terms, that's 3 of them. 3 measures of angle 4s equals 360. And that, you just write down what you did, I combined like terms. Then what can you do to figure out the measure of angle 4? Divide by 3. And you have the measure of angle 4 equals 120. And all I did was division. So there's a proof. I guess actually what they asked was what is the measure of angle 1? So since angle 4 is 120, angle 1 is 120 because they're equal. So that's substitution. Or you could put transitive property. Okay, so like this one, it says B is the midpoint of AC, C is the midpoint of BD. We want to show that AB equals CD. So, in this proof, we'd start off with our given. B is the midpoint of AC. That's given. Now, since B is the midpoint, that means it cuts it into 2 equal pieces, right? So that means then that AB equals BC. This is one that you will see in the future a lot. All that is that's the definition of a midpoint. So you can abbreviate definition of midpoint. Then we got to do this one. C is the midpoint of BD. That's given. So since C is the midpoint, we know that BC equals CD. Definition of midpoint. So now AB equals BC and CD equals BC. Since they're both equal to BC, what do you know about these two? They're equal. AB equals CD, and you can either put transitive or substitution. Transitive is probably the better name, but substitution would work too, because you could just put CD in place of the BC there since they're equal. Or you could put AB in place of that. But again, this is one that's later on, those types of proofs. Today we're just going to do some of the equation ones.